Hey, welcome, fellas, to this series of Cracking Hackerrank. Hackerrank is a technology company that focuses on competitive programming challenges for both consumers and businesses. Many computer science students in India as well as abroad begin their coding journey by first cracking some Hackerrank questions. Solving Hackerrank questions are indispensable to hone your coding skills, and in this series, I will help you tackle some of the excellent mind boggling questions on Hackerrank which I struggled to solve in initial stages of my programming career. I will post the problem link in the description of each video. So the problem we have at hand today is Grildland Metro by Nabila Ahmed. You can check the problem. The problem link is given in the description section of the video. So the problem says the city of Gridland is represented as an n cross m matrix where the rows are numbered from 1 to n and the columns are numbered from 1 to m. So we have a grid with n as a number of rows and m as a number of columns. Gridland has a network of train tracks that run straight in horizontal lines. So we have horizontal train tracks. In other words, we have the train track as RC1 and RC2, where R represents the row number, C1 represents the starting column, and C2 represents the ending column. So we have a track with a particular row number, and the track runs from C1 to C2. The mayor of Gridland is surveying the city to determine the number of locations where lampposts can be placed. Okay, so the mayor is trying to place lampposts and he wants to find out the location such that that location is not covered by a train track and lampposts can be safely placed. Okay, so we have been given a map of the Gridland and K train tracks. We need to find and pin the number of cells where the mayor can place the lampposts. So we have R, C1 and C2 with so and we have to play so if the entry is K is equal to 3. So for consider this case, this has 4 rows and 4 columns. So n is 4 and m is 4. The first row, the input is 114. The first row has a train track from 1 to 4. Similarly, the second row has a train track from 2 to 4. So from 1, 2, 3, 4, these 3 cells, from 2 to 4 we have a train track, and 3, 1, 2 is the third train track from 1 and 2, and similarly the fourth from 2 to 3. Okay, see, the indexing is not from 0, it is from 1. And to find out what are the places which are not covered by train tracks, so we have these 5 cells indicated in red where lampposts can be placed. So we have to find out the count of these. Let's look at the problem constraints. So we have the number of rows in the Gridland as indicated as n, m is the number of columns, k is the number of train tracks, and k and 3. Okay, so k is in the form of an array and the track is in form of a multi-dimensional array, and it has 3 entries like row, start and end. Okay, so let's look at the problem constraints. So n and m is 10 to the power 9, so we can't make an array. Because n and m are very large, at the power of 10 to the power 9, so we can't make a 2D array. Okay, and k is in 0 to 1000 and r is less than n. So the row number will always be less than the number of tracks, and C1 is and C2 is less than m, which means that the column number will be less than or equal to the maximum number of columns present in the grid. So let's look at the solution of Grildland Metro. So we have a grid. Okay. So let's look at the solution of Grildland Metro. So we have a grid, and n is the number of rows, m is the number of columns. We have train tracks running horizontally on this grid. Now we have to find the the squares where the train tracks are not running. And one important thing to note that is that we can have train tracks inside of train tracks. What does that mean? Suppose this is row 1, row 2, row 3, row 4, row 5, row 6. M is 6, M is 1, 2, 3, 4, 5. So M is 5. Now we have a particular rail tracks, say query, say 4 to 5. So on the fourth row we have this as a first rail track. Now it can happen that the next query be 4 1 3, or the rail track as this. So there would be an overlap. There will be an overlap such that there the rail track was from 4 2 to 5, and now another rail track has come which does a partial overlap from the left side. So this is a case of overlapping problems. And there are three overlaps to be considered. First is a partial overlap, other I should say. First is a no overlap. Second would be a partial overlap, and third would be complete overlap. Complete overlap. Now, say, what do I mean by each of these terms? Let us see that if we have a particular query, say 4 1 3, and another query, say 4 4 5. Say so 4 1 3 would mean, okay, let's make it 3 3 1 3 and 3 4 5. So 3 1 3 would be this, and 4 1 5 would be this. 3 1 3 is in green and 4 1 5 is in black or blue, purple, pink color. So in this case there is no overlap. The tracks are not overlapping. However, we can also have a case as six 1 5 and 6 3 4. So 6 1 5 would be this complete, and 6 1 6 3 4 would be this here, small one. So here we could see that there is a case of complete overlap. This is complete overlap. This one was partial. This one is complete overlap because the second train track 634 is lying completely inside the first train track 615. Okay, I'm sorry, this is not partial. This is, yeah, this one would be no overlap. This one would be no overlap. This one is no overlap. This one is complete overlap. Now let's see the interesting part, which is partial overlap. The partial overlap. This thing is confusing. So let's see, what do you mean by partial overlap? See, if I have this as my particular train track, this one is 2 2 4, and I have another overlap this. This is 2 1 2. So here in these cases the overlap is not complete, but the track 212 is not completely inside the track 221 224, but a portion of it is inside the track 224. So this overlap is partial. So we don't so on the basis of input provided, there can be no overlap also, partial overlap also, and complete overlap also. This is an partial overlap from the left hand side. Similarly, we can also have a partial overlap, say like this. This is one track, and here from the right hand side. So okay, now why we are actually seeing all these overlaps? See, since we cannot create, we cannot we cannot create array. I cannot create array since the constraints don't allow me. So since I cannot create an array, my approach would be to create linked list of size linked list. Now see, if I have some queries, let me just take a new page and yeah, so if I have another grid and here, and I have cases, the cases of the train tracks. What I'll do is, instead of counting the number of vacant squares, I'll count the tracks having I'll count the squares that are covered by train tracks. I repeat, instead of, okay, I'll just write it down also. Instead of counting squares covered not covered by train tracks, I will count what? I will count tracks covered by train tracks. I will count the cars that are covered by train tracks, and I'll subtract just the squares that are there. I'll subtract squares that are covered by train tracks. I'll subtract them from the total number of squares, which will be simply n into m. The total number of squares will be simply n into m, and I will subtract the squares covered by train tracks. Okay, now and what I'll do is, I'll make a linked list of each track. So first of all, for example, if I have a query as 2 3 4, I'll have a query as 3. This is R, C1 and C2. I have query as 3 1 2. I have query as 3 5 6. Okay, and I have query as 4 1 3. So what I'll do is, I'll first see how many different rows are there. See, this is one row, these two are same rows, and this is another row. So I'm having 3 unique rows. Tracks are running in 3 different rows. So what I'll do is I'll make a map. I'll make a map, and that will be an unordered map. An unordered map. In this unordered map, I will have I'll have two things. I will have the keys as the track number or R, and I'll have the value as the head of a linked list. Head of a linked list. Okay. So for the track 2, I have a linked list. I stored the head of the linked list in this map. For the track 3 and for track 4. Null. I'll make you understand what I'm doing. So in each of the map value, we have the head of a linked list. So for r is equal to 2, we'll have the linked list head, this linked list head. For r is equal to 3, we are having this linked list head. For r is equal to 4, we are having this linked list head. Okay. Now this head of a linked list this is the head of a linked list. By using the head, we can traverse the linked list. And what this linked list will store? So this is head of 2. This is head of 2, head of track 2 or head of row 2, head of row 3, and this is head of row 4. Now in head of row 2, what I will do is, I have the first query is, what is the first query? I have a 2, 3, 4. So I'll say, okay, since this is the head of 2, the track starts with 3 and ends with 4. And head of 3, what I will do, the track starts with 1, it ends with 2, and there again we have a 3 track, and it starts with 5, ends with 6. Okay. Now similarly with the head of 4, we have the head that starts with 1, the train track starts with 1 and it ends with 3. So by how I can scheme here? By seeing all these queries. Okay. Now, so I include the std_c++.h to include all the header files. I'm using the basic namespace std, and I've created the main function. So now I want to create the track, the linked list of the track. So a basic node of the track linked list will have 3 properties. First of all, it will be the usual head pointer, next pointer to the usual next pointer to the node of the linked list, and it will also contain a start and an end value indicating the start point and the end point of the track. Now yes, let me return the 0. Yes. Now I have to create a function that will create the node of a linked list. So in order to create the node of a linked list, I will create my create node function. Oh, there is an error in the int. Oh, I have forgotten the semicolon beside the track. Okay, I'll do it. So I create the new track function. I'll create the new node function, which will return a new node. And yeah. So the new node will be created. So it will accept some data, or it will not be data, it will be start and end. It will accept the start and end, and it will return me the node. So okay, let me create the node. Track node is equal to new track. Yes, that will create a new blank node, and here I'll now initialize all the I'll put the values for the start and end. So now in the function call, I change it to int start and int end. Yes, and I put node start is equal to start and node end is equals to end. And what I had to do, I had to return the created node. So yes, I put return node. Yes, now I had to create a function which will insert the node at the end of the linked list. It will insert the newly created node at the end of the linked list. So this function insert node, which will accept the head of the linked list, and it will also accept the node to be inserted, that is node. Now I'll check whether if the head is null. If the head is null, that means the list is empty. So we'll have to assign the head to the new node and return the head. Okay, now this is the case one. Now it can also happen that the linked list is not empty, or head is not equal to null. So I'll make an else case where the list is not empty, and I'll travel through the linked list. Through using a while loop. I'll travel to the end of the linked list, and when I reach the end, I will uh, let me just traverse it. Head is equals to heads next, and and after the completion of this while loop, the head has reached a point where it is pointing to the last node of the linked list. So here, why this else is showing in an underline here, I have to also create a node copy which I'll have to return it. So I create a node copy, and at the head I'll have to, why it is showing an else, I have to just initialize the new node. Oh, it's saying an indentation. Well, see, it doesn't use indentation. Let me just fix it. Okay, yes. Now, so I'll just return the copy node, the original head. Okay, so these two functions have been created. Now the insert node function, what it will do is, it is a function that will insert the node at the end of the linked list. Insert the node at the end of the linked list, and new node, it will function. It's a function that will return or create the new node at, well, it will not be at the end of the linked list. My mistake, I written that. Okay, now it's just to create a node of the linked list which will be pushed at the end of the linked list. Now now what I want is, I want to create an unordered map that will be having each that will be having keys as the row number. That will be having keys as the row number, and the corresponding tracks as the track that will be stored as a linked list. The corresponding track to that row number that will be stored as a linked list, that will be the value to that particular row, which will be the key of the linked list of the map. So now first I include the unordered map header file. So I write hash include unordered map. Now I have to create an unordered map. So for that I write the code unordered map. It will be without the angular brackets. So just let me remove the declaration, and now this unordered map will have keys as the row number and the value as the head of the linked list. Now this the head of the linked list. Now this linked list, it will be it will represent the track. It will represent the track of the row. So the value will be the head of the linked list. So I create, now I read the prompt. It says the first line contains three space separated integers n, m and k, where n is the rows, m is the columns and k is the tracks. So I create the corresponding n, m and k variables. Now I create a for loop and travel from 1 to k using the loop variable I. I accept the input using the cin command. Now at the iteration of the loop, I declare the variables are c1 and c2, indicating the row number and the start and end point of the track. Now I take the input, I read the problem constraints, and I want to create the a node. I want Now I make an interesting observation that by default all the track values for the map will be null. That is, that all the pointer values or all the values of every key of the map, it will be null. So what we do is, first we extract the head value of the um, each link list. So we extract the head value of the each linked list, which will be made the head value of each linked list. This will be first, it will be null. So what we want is that we want it not to be null, but we will be wanting it to uh, be assigned to the head of the linked list. So what we do is we repeatedly iterate using a for loop and see, and we check if the head is null. So we assign the head node, or we assign a new node to the corresponding map key. So if a particular row does not yet have any particular track, we first make a new node and assign the first node node belonging to that row as the head of that linked list corresponding to that particular track row number, corresponding to that row number. Okay. Next, I extract the head pointer of each of the given row. Now I check if the head pointer is null. If that head pointer is null, that means yet no track has been laid on that row, and a new track with the new values are c1 and c2 is now being laid and on this row, and this is the first track to be laid on row R. So what I'll do is I'll assign the track map row R, or the value at row R, to the new node that will go from c1 up to c2, which will indicate a new track that will be laid on the rth row from c1 and c2. We didn't check for overlaps here because there will be no overlap here, because the other track didn't contain any other track, so there is no possibility of an overlap. And the rth track and the track from c1 and c2 was the first track to be laid on this rth row. Now we create a variable answer and assign it to n cross m, where answer would be the total number of squares present in the grid. Now we have to decrease this answer variable according to the tracks that are present in the row. So we create a function update answer, which will subtract the the squares, row number of squares, from the squares covered by train tracks. So I create an update answer function and pass the track pointer head of the linked list, and now I iterate using it a while loop. And if there is a node, I decrement the value of answer as from according to the number of squares that are present in that linked list. Now see that I have passed answer as a reference variable. I written int and answer. I did it because I want to decrease the value of the original answer. If I would pass if I would not pass it as a reference, the original answer would not change. Okay, let me write it down as a comment. So we pass answer as a reference. We pass answer as a reference because we want to decrease the value of the original answer. We could also pass it as a pointer. So in order to understand this portion, we have to consider overlaps also. So when we are taking inputs in the form of RC1 and C2, and we have inserted the nodes, now it's time to check for overlaps. So suppose at the rth track is represented as a one dimensional array, and it has all inputs, many squares. It's a long row, and it has around 7, 8, 9, 10, 11, 12, 14 as the number of columns. Now there is a track that we want that is already present, that is from 5, 6, 7, 8, and we have other track from 2 to 3. So we have a linked list representation of that would be from 2 to 3 to 5 to 8. Now we have another input which says to lay the track on from 10 and 11. Now it's very simple. What we'll do is we'll simply add this 10 and 11 to this linked list, and the track will be laid down. But suppose if it asks us to lay a track that overlaps with one of these tracks. Suppose it says to lay the track from 1 to 3. Here in this case we have to make cases, like how depending upon the nature of the overlap. Now suppose, so here this function, this is the function where I made, its name is update answer. It's update answer, and here what it takes is, it takes a start and an end value. It takes a start and an end value. This start and end value will correspond to the C1 and C2. Okay, the start and end value it takes, and it also takes some the head of the link, the head of the map, that was the current point, and it takes a start. So yeah, it just takes a start and end here. So what we do is we first start the head of the linked list. This is the head, this P is the head of the linked list that was already present. That this is the head of the linked list that was that contains the track that were already present here. Now we check for overlaps. Now if there is no overlap found, what we'll do, in any of the linked list there is no overlap, we can simply jump onto this last line out of the while loop, and we can simply add the track to the end of the linked list if no overlap is present. But if there is an overlap, what we'll do? If there is an overlap, what we'll do is we'll check for overlaps. We'll first check for overlaps, and if P is, now we'll say, suppose the P was the track that was already laid there. So if P is start and P is end is suppose here, and it says p first case is p start is greater than equals to the start. So this is the start, that the track we that this is c1, which is the start, which is the new track that we want to lay, and the end value of that is less than equal to the end value of here. So this is the end. Now what will happen in such a case? Such a case, this is the track that was already present, and this is the track we want to lay. So what we'll do is simply shift the start point of the first and of the already laid down track, and we'll adjust it to and move it to this start. That we do, move this to the start, so that the track is extended towards the left. Now next case would be that the p's start is greater than equals to start, p's start is less than equals to starts. Okay, so p's start is less than equals to start, and p's end, this end is greater than equals to the end. Okay, so something like this, p's start is less than equals to start, and p's end is, or it means that the track that we want to lay is completely inside the track that was already present. So in this case we don't do anything, because there is already a track, much bigger track that has already been laid. Now the third case is third case is this is the p's start, this is the p's end. Third case is p's start is greater than equals to start. Okay, this is the start, and the end value is greater than equals to the end value that is present. Okay, so now we want to extend the track both leftwards and rightwards here in such a case, because the track that was already laid is inside the track that we want to lay. So we'll just shift here accordingly. P's start is equal to start, we'll shift the p's start to the left, p's end towards the right, and we'll do it. Next and the final case, it will come when the p's start is less than equals to start. Okay, this is the start, p's start is less than equals to start, and the p's end, that is less than equals to the end, something like this. In these cases, what we'll have to do, we'll have to shift both the start. What we'll do, we have to extend the end, this end needs to be extended. But when will this end be extended? Only when this end has a value that is greater than equal to the start value. This end has a value that is greater than equal to the start value. Why? Because it can happen that this is the p's start, this is the p's end, and this is the start, and this is the end. In such a case also, the p's start is less than equals to start, and p's end is less than equals to end, but there is no overlap. So for to check overlap, what we'll do is we'll see that the p's end is p's end, this is the p's end, is greater than equals to the p's start, and there's an overlap, and then only we move the p's end here. You might be thinking there might be a case when there is a p's start and p's end, and this might be the start and this is the end. Here in this case, yes, we have to shift the p's start towards the start, but we have checked it here because p's start is greater than equals to start, and p's end is greater than equals to end. See, we have checked it here. Where here also we need to check that the end is here. I had to just, so here also I have to add a statement here that if only we have to do it if there is an overlap. So if if p's if end is greater than p's start, greater than or equal to, then only we have to do this. Yeah, here also we have to put this statement. Okay, so this is all about overlaps. No, so what we can do is we can just copy this code, this entire piece of code, and let me just move it onto my problem, and I make a function. I'll say void check overlap, check overlap. It will take an integer start and an integer end, and this is the function. Okay, so now let's look at the code. So this is the code, and I had to just add something. I add index here, and now this m is also missing a declaration. See, m is also missing a declaration, so I this is our unordered map here. Okay, and one thing I have also have to add is that here in the check update answer function, I had forgotten to update the head pointer, so this will be head is equals to heads next. And now what we do, we have checked for overlaps also. Now we also wanted to update the answer whenever. So this is the code for updating the answer. What is that? We iterate to all the entries. We have created an iterator. We have created an iterator here for the track, for the map, and in the map we iterate to all the rows, the keys which are the rows, and in every value, this is the IT's second is head of rth row. So this is the one particular row, its head. We have passed it to the update answer function, which will decrease the answer. And now I can just run the code. Let's take some time to process. Yes, it's got the correct answer, and now if just hit on submit. There will be track copy is equals to m's index, copy of that initial pointer. Now let's see. Okay, the declaration is causing problems here. Also in the function it will be long int here too, here too. Now if I hit submit, okay, it's not a pointer, I suppose. Check overlap is there in the update answer function. It is int and percent answer track head. Let me see what's the error. IT second is that solution initializing argument to avoid cannot bind non-constant L value or difference of type int ampersand t. I guess it's because I used int ampersand. It would be so null value of int. That is strange. Yeah, because it's not int. It's long int. Okay. Now just me just submit the code. Let me just submit the code. Yeah. So there was a lot of trial and error while I was um, trying to solve this question. So I'll be posting the correct code or the solution to this problem as a form of a Google Drive link. So you can open that link and get access to the complete code. Meanwhile, if you like the channel, please do consider subscribing it to iTalk Code and share it with your friends and spread the coding knowledge. Till then, happy coding.